Now, there are times that you may have to apply the rule of the geometric term or the general formula for a geometric sequence in using it to finding particular terms or the first term or the common ratio. How does this also work out? Let's look at this set of questions. A geometric progression has the value of its third term being 8 and the ninth term is 64. Find the common ratio and the first term. So how do you do with that one? Okay, all right. Let's see. It says that as the problem just showed, I just say it for emphasis. It says that we have a geometric progression and the third term is 8 and the ninth term is 64. The third term is 8 and the ninth term is 64. We want to find the common ratio and the first term. All right, so let's look at that. The third term is 8 and T9 is 64. Okay, what is the common ratio and the first term? Remember, when you have problems of this sort, what do you have to do? Remember the general formula. It is always important, the general formula. The general formula. We are saying that the general formula of a geometric progression is AR to the power n minus 1. AR to the power n minus 1, where R is the common ratio, A is the first term. Okay? And we are saying that T8, the third term is 8. So we can just continue from here and say that T3 is equal to AR. What is 3 minus 1? That's going to give you squared, okay? And we are saying 8 is going to give you AR squared. So that's what the problem tells us. 8 is equal to AR squared. The third term is 8. It says that the ninth term is 64. Likewise, we just work with that. T9 is equal to AR. 9 minus 1 will give you 8. Okay? So here we can therefore say that 64 is equal to AR raised to the power 8. Okay, so now guys, watch this. Because the geometric progressions by their nature, they deal with like multiplication and division. Remember, because it is a common ratio, and ratio is kind of a divisive effect. You have a number and you are multiplying, okay, and you have to divide. So most times for arithmetic progressions, usually you would have the terms being compared. In situations where the terms are compared, in order to try and find the relation, we try to kind of subtract. I'm very sure that when you solve some problems in books and other stuff, you come across that. Geometric progression is of a different sort because usually the terms are generated by the multiplication of a constant or a common ratio. When you want to make the comparison, you always tend to divide. You get it? All right, so let's see. The question says that we should find our common ratio and our first term. 8 is equal to AR squared. Okay, we'll see that clearly. 64 is equal to AR raised to the power 8. So what do we do? Okay, you realize that here they are multiplied, there they are multiplied. So the only way you can take away the multiplication is to divide. Get that? Is to divide. That's the algebraic approach. You divide. If they were adding like A plus R squared or let's say A plus R8, then probably you subtract to allow the A's to go away. But this is a single unit, multiplying a product. That one too is multiplying a product. So how do you split it away? How do you cut any of the term off? You have to divide. Okay, so we divide the ninth term over that. Okay, that makes it easier. So you have AR raised to the power 8 is equal to 64. We divide by its corresponding part, AR squared. Then 64 also divide its corresponding part, that gives you 8. So what do you get there? Okay, you're going to have R raised to the power 6 is equal to 64 divided by 8, that should give you 8, right? 8 times 8 is 64. Well, what is your R? What is your R? Remember, mostly in examinations, the R's that you would work with, it doesn't actually happen all the time in real life. But for example purposes, the R's that you work with would usually have to do with fractions, and sometimes it may test your understanding of the use of other forms of numbers, including irrational numbers, or even in some cases sets and all that. So you should know how to work with that. So R raised to the power 6, don't just hurriedly just take a calculator and try to work out with a decimal, because there may be some other subparts that you may, what do we do here? Okay, so R to the power 6, this means that our R is equal to 816, okay? Yeah, so we can reduce this. R is equal to 2 cubed, because 2 cubed will be 8 times 1 over 6. So what happens? Your R is going to give you 2 raised to the power half. Or in other sense, you can just simply say that your R is equal to root 2. Your R is equal to root 2. Okay, so if your R is equal to root 2, what is your A? Let's come here. You can just slot our A in here. We can say that our 8 will be equal to A, then root 2, which is our R squared. What happens? Our 8 is going to give you 2A. Hope that is clear. Don't be confused. 2 will take away the root. That will give you 2 times A. Okay, so you divide here by 2. You divide that side 2 by 2. This will cancel that. Or A will be 4. Okay, that is it. You get your terms, expressions, you divide, you get your R, you slot it back into the equation. So that's good. That's just what you're going to get. Your first term is 4. Your common ratio is root 2. The second and sixth term of a GP are 8 over 9 and 4.5, respectively. Find I. R, that's the common ratio. II, the first term. III, the third term. So this second question on this part is saying that the second term and the sixth term of a GP are 8 over 9 and 4.5 respectively, just like we saw in the earlier question. Okay, the second term, T2, is 8 over 9. And we are saying that the sixth term, T6, is 4.5 respectively. The question is asking us to find our common ratio, our common ratio, the first term, and the third term. So what is your common ratio? What is your first term? And on the basis of that, what's your third term? Guys, how do you go about this? I'm sure by now it's a bit easy for you to go around it, right? But let's just try. Let's just try. So remember our general expression for geometric progression, just as we've been doing. Remember, exam, a bar. What is your expression? Okay, you just have to know what to do. Okay, so your general term, Tn, will be A, R, n minus 1. And we are saying that T2 is 8 over 9. So T2 will be A, R, 2 minus 1. And what is 2 minus 1? That is 1. Okay, so we can say 8 over 9 is equal to AR. Hope that is clear. The same principle, we extend it to our T6. Now, because it's 8 over 9, it's only logical that we try and convert the 4.5 for it to also look like an improper fraction. 4.5 would give you 4 times 2 is 8. 8 plus 1 is 9. 9 over 2. So our T6 will be 9 over 2. Okay, our T6 will be 9 over 2. All right, so let's see what T6 will mean. T6 will give us AR, instead of n minus 1, because this time is 6, it's going to be 6 minus 1. And what is 6 minus 1? 5. So our T6 will be AR to the power 5. Now the problem says that your T6, your sixth term, is 4.5. We've already found out that 4.5 is the same as 9 over 2. 9 over 2. So we'll just put our 9 over 2 equals to AR to the power 5. So what do? Like in the previous example, this is a geometric progression. So we try to divide. You try to divide, okay? Try to divide the terms so that we can arrive at what we are looking for. So let's see corresponding terms. AR to the power 5 will divide the AR, okay? Then we take its part 9 over 2 divided by 8 over 9. So what happens? Obviously, our A's will cancel. We are going to have R raised to the power 4. And what do we get for that? 9 over 2 divided by 8 over 9. Can you work that out? Okay. For the burden for some of us, let's just do it at this corner, okay? So you've got 9 over 2 divided by 8 over 9. That's going to give you 9 over 2 times 9 over 8. So what do you get there? 81 over 16. Is that clear? So you're going to have, this one is going to give you 81 over 16. Okay? So our R, since from our basic indices, our R should give us what? 3 over 2. Our R should give us 3 over 2. Because when you take the root of that to the 4th degree, you should have your R being equal. So this is our common ratio. Our R is 3 over 2. Our R is 3 over 2. Now the question says that what is your first term? What is our first term? Since we know our R is equal to 3 over 2, it should be easy for us to work out our first term. Here, we are saying that 8 over 9 is equal to A over R, AR. So we can find our first term from this. Let's just slot it in there. So 8 over 9 should be equal to A, our first term, times our common ratio, 3 over 2. Okay? So this implies that our A will be equal to 2 will go there and multiply. 2 times 8 all over 3 times 9. That should be easy for us to solve, right? Okay. So that's going to be our first term. Okay, so our first term should give us 16 over 27. You see how easy that is? Okay, so you're just able to work it out and you shouldn't have any problems at all. Then it says that, what is the third term? What is the third term? Any idea how we can find the third term? That should be easy, right? Because now we know our first term to be 16 over 27. We know our common ratio to be 3 over 2. So we'll find the third term. Should be perhaps the easiest thing on the planet. Okay, so let's try and figure that out, our third term. Okay? Let's try and figure out our third term. How do we work out our third term? All right. So let's see how we will just find our third term. Third term will be T3, obviously. So our third term will be A, R, 3 minus 1. That will give you AR squared. AR squared. A times R squared. And we know our A to be 16 over 27. So 16 over 27 times our R is 3 over 2. So we get 16 over 27 times 9 over 4. Right? So what do we get? Basic simplification. Our 4 can go into the 16. 4, 4, 16. Then our 9 will go there, 3. Yes. That's our third term. Our third term should give us 4 over 3. Okay, so we've got everything covered. Our common ratio, 3 over 2. Our first term, 16 over 27. Then our third term is 4 over 3.